So did I get these wrong on the back because I put mass, like when you're increasing, decreasing the temperature?
I don't remember what you put exactly. But if you put something about temperature being related to mass, then you definitely got it wrong.
Well, I don't even know why I put mass on that.
I don't either.
And I knew what I was trying to say, but like I knew mass was the right word. Man.
So far, so good.
Yay.
And I own this.
My
If I would have
day
just
was-
got
my day was
these
pretty
back
good until I got
first, I would have been up,
Yeah.
bro. I'm telling you, if I would have got the back first, I would have had a great grade. I literally just missed the first one is on the back.
Okay, so the first free response question asked you
Okay, you took all the books and dispersion. Bro. I'm dead mad. Oh, if I would have got the back, I would have
Okay.
What is what?
Oh, well, he put like okay. He exited out and then put okay.
Melting point is one.
All right, that's pyridine, right?
Yes, sir.
That was benzene.
Yes, that's true.
So they're asking you why this one is soluble, this one is insoluble in terms of water soluble, right? Okay. So solubility has everything to do with what? Whether something is, whether they're what's match, their polarities, right? Okay. And several people who somehow put that water was nonpolar. I don't know how. In 2 years of chemistry that we missed the idea that water is definitely polar, okay? Definitely not symmetrical. All right, definitely polar. Okay. So like the regular class is having a quiz this week where you fill out the little chart about methane, water, ammonia, carbon dioxide, right? Water's polar. Okay. So water's polar means that if pyridine is water soluble, it must also be what?
Polar with, well, mixable with water, which means it's soluble with pyridine.
Not what I asked.
Say it again.
If pyridine is soluble in water, then that means pyridine must also be what? If water is polar, pyridine must be polar. This is not a complicated concept, right? What's the saying that we use that we said we wouldn't put on the test? But
Like
dissolves like. So if water and pyridine will mix, then they must both be like each other. We should know water's polar, which means pyridine must be polar. If benzene will not dissolve in water, then benzene must be what?
Non-polar.
Non-polar. So, okay, what is making pyridine polar?
The hydrogen bomb. Well, the N like
Nitrogen, right?
Yeah.
The nitrogen. The lack of symmetry caused by the nitrogen, right? We've said that hydrocarbons are always what?
Non-polar.
Non-polar, okay? That's a perfectly symmetrical hexagonal shaped deal right there, okay? This is not, because this has something else in it besides carbon and hydrogen, okay? We said several times that when you take a hydrocarbon and if you put oxygen or nitrogen or anything else in it, it's going to make it polar, right? Okay? So, water soluble, not water soluble. Got it?
That one I got.
For this one, why did you put okay for this?
I wouldn't call that hydrogen bonding, but they did in the answer key, so I changed it.
Can we do
in the future, don't put hydrogen bond, just put that at the end.
Good answer. All right, the second one, everybody should have gotten right because we used this example in class. And I said that this example is used on every AP exam in some way, shape, or form.
You took off 1
Know
point.
it, okay? So ethanol versus dimethyl ether. That's, we have to understand this right here, okay? That is the next one, isn't it?
Well,
Or is that B?
Yes.
Yes.
C. B is the silicon dioxide,
Oh,
right? Okay. All right, so
let's see.
why is the boiling point of that different from the boiling point this?
Because it has
Polar.
hydrogen bond.
Okay. Now, let's explain something because there's several people in your writing that are obviously confused. Okay. When we're boiling something,
Mr. H. I'm sorry.
okay. There's an intermolecular force that's attracting right there, right? And there's an intermolecular force that's attracting right there. Okay? Now, when we vaporize or boil a sample of ethanol, what is being broken?
Intermolecular forces.
Okay? The dash line or one of the solid lines?
The dash.
This, right? This. Not that, right? Okay?
Right.
Everybody understand that?
Yes.
Sure?
Yeah, it's cool.
Okay.
We did
I read
some
several
like that.
papers that implied that we were trying to talk about this bond. Okay, versus this one, or that one, or something, I don't know, okay? All right, so the physical change of vaporizing something is overcoming this attraction or this attraction, okay? A chemical change of decomposition or anything else would overcome one of these attractions, right? Somewhere else, all right? That would be a chemical change. If you break a covalent bond, it's a chemical change. If you overcome a physical attraction, that's a physical change, all right? So this has a higher boiling point than this substance because apparently this attraction right here is stronger than this one, right? Okay, because this one is a more polar substance.
Right.
We recognize that by seeing the hydrogen bond to the oxygen instead of to the carbons. Okay, hydrogen bonding versus London dispersion. Some people said that that was non-polar. That's also incorrect. Okay,
Well,
this is very polar because it's bent, right? Just like water. Okay, got an oxygen with two lone pairs in the middle.
why did you take off one point just because I did put dipole. I literally put the whole thing right. And I just didn't put dipole. I put Derimethyl has LD. And you took off a point because I didn't put dipole.
What did you put? Read it.
Ethanol is polar with London dispersion, dipole, and hydrogen bonding. Where dimethyl
Dimethyl ether.
has LD. Since ethanol has a hydrogen bond, this makes it stronger, more polarizable, higher boiling point.
Yeah.
And you took up a point.
Yeah, because you implied there that dimethyl ether is non-polar.
Oh, okay.
Which is definitely not the case.
I'm sorry.
All right, we got to know that one. You're going to see that one again. Okay, mock exam, AP exam, for sure that you're going to see that one again.
For silicon, like with the SiO2 and the other one, that's for
Anybody have a yellow highlight?
like breaking covalent bonds. There was one question on there that
I'm
was
getting
not.
there. Let me
Okay,
get there.
okay, that's not
Let
what
me
that's
get there.
about.
We're going in order.
I'm sorry. I apologize.
Huh?
I
Let
apologize.
me get there.
We'll see until. We'll see until.
Let's do one question at a time.
Oh,
I gotta get this now.
Yes.
I gotta get that, okay? right.
Here you go. Thank you so much.
The next one is sulfur dioxide versus silicon dioxide.
Can we write on our test when we have it?
Yep.
Can I see your might as well just use it.
Good catch.
All right. This is the molecule. Okay, does it look like the word molecule at all?
Is this something? Is this something you want?
What?
Is something
No. It's been worse than.
Is this asking about melting or melting, right?
melting? Yes.
Yes, if you're going to melt sulfur dioxide, these are resonance. We're not going to worry about that at the moment. Okay. And you're overcoming this dipole and London dispersion attraction right there, right?
Mhm.
That's what you got to overcome to melt that. Okay. It's not going to take a whole lot, but that's not real strong.
Oh,
Right.
Yeah.
If I'm going to melt silicon dioxide, this is a what? Is this a molecule?
It's a covalent.
This is a covalent network. Okay, here, to melt this, I'm separating this molecule from this molecule that are somewhat attracted by London dispersion and dipole-dipole interactions right there, okay? Takes a little bit of energy, you're gonna pull them apart. If I'm going to melt this, then I've got to break what?
The covalent.
Covalent bonds have to be broken, okay? That's gonna require an enormous amount of energy. So you see on there, the temperatures are drastically different, right?
Since that's covalent, it makes it stickier, right?
This ain't about
Not
this stick.
stickier?
No,
Okay.
this is about having to essentially decomposing it.
Okay.
Covalent network solids.
Am I wrong? Isn't it like carbon? Isn't it carbon, silicon, germanium, and boron that are kind of like covalent network solids?
They can.
Wait for me long. Make sure I get this. So, covalent, pretty much you're having to decompose it, which makes it like, is why the
There's
temperature.
much more energy to do.
Okay.
So the temperature number is telling you how much kinetic energy you have to increase by to make the process occur, right?
Mhm.
All right. Next one is what? Chlorine and hydrogen chloride.
Yes, chlorine and hydrogen chloride. And chlorine has the larger temperature.
Can you do this every day?
What?
Like stand up there and like teach. I'm getting it.
What do I do?
It's hard for me to
yell at me.
Yeah.
Sometimes you yell at me.
Sometimes you yell. Sometimes you yell at me.
Like every day we do like a first one question like at the end of the like at the end of the class.
Try that.
Like
Yeah,
I'm for
actually,
real, Kendall. Like you doing this and not being mad at us and just doing this. Like I'm learning
Yes.
more than I've learned these past 3 years.
And like you make it, and you not being mad at me makes me feel so much better.
And it makes it everything peaceful. So let's continue this because I'm learning more in this time than I have the last 3 years.
So the problem with that is
All right.
Great
One
idea.
One period.
if we don't have time to just answer questions, okay? Because when would we ever talk about what you have to know to answer the question? So So we're answering questions now, stuff that we spent 3 weeks talking about. It's different, right? So when are we gonna talk about what we gotta know to answer the questions? Now, the idea of flipping the classroom, to use teacher lingo, is that y'all go home and figure out all the information, okay? And then all we do in class is answer questions. That's a great, wonderful thing in theory, except I'm yet to find a high school class of students who can go home and figure out chemistry on their own, including you.
It felt like we did that last week. Look at these videos. That's what it felt like this unit. Was like, that's what it felt like we were doing. Like we went home and learned it.
Yeah, like that's
I'm
what
so
I did.
serious. That's what it
That's
felt like
for real
this
what I
week.
did.
So like I
You know
just
what?
wish like maybe we could do this where we don't ask questions. Will you limit us? Three?
I had
No,
two
you limit
less.
us
I had
4
two less
questions
units,
the
two.
whole class and like
Look,
teach it.
I'm all about it. Y'all go home and watch AP Classroom and Khan Academy videos, and all we'll do is answer questions.
No, I didn't say that.
But Mr. Caleb,
That
I
is
did.
what you
I
said.
said you limit us to 4 questions.
Yeah,
Like,
'cause I only
we
had
be
two.
asking like
4 questions a
15.
day?
Yes.
I only asked
We
two.
can't do 4 questions a day.
That's we do more than that. Though.
Well,
Two
I used to do
questions per
more than
person.
that.
No, I'm
Questions
talking
per
about-
person.
No, I'm talking about stupid questions like
You have to
is your
turn in a
favorite color
card or
blue or
something every
yellow?
time you ask.
Well,
That's
can
not
we-
what we're talking about though. We're talking about working answers to actual questions on the board.
Oh.
Because you're saying that's the best way to do it, and I don't disagree. The problem is when do you going to learn the background information to answer the questions?
Yeah, I'm the type to go back
If
home
I
and
don't
watch
get
the
up here and
videos.
talk about the facts of chemistry first, okay?
Okay.
The way that you could do it is you go home and watch AP Classroom and Khan Academy videos, and then we'll just sit here and do actual FRQs and stuff in class. I don't have a problem with that at all. Problem is, well, the real problem is most people in here are not gonna do it.
What's the difference in this year and last year? Because like last year, like
Not much at this point.
it feels
Even in grades. was there
well,
a difference?
Grace, yes, but
Not much.
okay. It feels
What's the
super
next
different.
question?
The next question is, yeah, the
HCl versus
CO2.
CO2.
And CO2 has 238 and HCl, never mind, don't know.
Okay,
I know, like he's done with me.
this is
I've been nice. I ain't gonna ask no questions here. I'm gonna ask
this is a non-polar substance, right? Got all kind of weird answers on this one. Somebody said that was a covalent network solid. Some people thought HCl was ionic. I don't know. Anyway, so that's not a covalent network solid. Okay, that's just 2 diatomic molecules that are attracted to each other through what? London dispersion. This is not ionic because it doesn't contain a metal. This is 2 covalent molecules that are attracted to each other by what? London dispersion, dipole-dipole. Okay. Now, our initial thought is that dipole-dipole would be a bigger deal than London dispersion. So HCl should have the highest boiling point, but it tells us that that's not true, right? So we got to figure out why. That means that this London dispersion must be stronger than the combination of both of those. That's the fact that has to be true because that's got a higher boiling point, right? So why is that? Because this has a lot more electrons and it's more polarizable. Specifically, this has 34 electrons and this has 18 electrons. Okay? So this is more polarizable.
It kept confusing the mass. I guess because I thought it has more electrons, it makes it bigger. Like, it makes the electron cloud bigger. You know what I'm saying?
Yeah, but it's not about
It's
being
not about
bigger, it's
that.
about it being polarized.
And I put that. I just put mass. Like, I put greater mass, more polarized instead of greater electrons.
Mr. Kittle.
Do you see how I put it?
Electrons instead of mass.
Yeah.
After we get done with these FRQs, can we go over some of the MCQs? Just some. I have 5.
Sure.
I missed 5.
Yeah, let's do the back page, because that page blew me in. I was
Go
doing
ahead.
really good on this.
Yeah, we
Let's
can do
the
the
back.
next one.
What's the next question?
22, the next 7 FRQs.
It says,
Great.
describe the effect of raising the temperature on the motion of the CO2 gas.
Temperature increases kinetic energy, which increases velocity, right?
Yes.
Increases
temperature increase.
You said kinetic energy and or velocity, you would have
Okay. So the next
got.
one,
Second one was find the pressure or something,
Yeah, can you write that one out?
0.99.
yeah,
So what did they
wait,
give you?
They gave us,
I just did
we had
my
200, it would be P1, D1. At first we had 299 Kelvin, that was the first temperature.
299.
Mhm.
And then our atmospheres was 0.70. And then our T2 was 425. And we're trying to find the pressure. So it'd be like P1 over T1 equals P2 over T2. It's 22 B.
I wish I had time.
Oh,
So we took the ideal gas law that day and used it to derive a whole bunch of stuff, right?
Mhm.
Ideal gas law itself, and there's the combined gas law, and then there's, from that you get Boyle's-Farmer Charles law, Gay-Lussac's law. Which one is that? Charles, Gay-Lussac, I can't remember. Anyway, it's one of them. We don't worry about the names so much. We're looking for the final pressure after the temperature was changed, right? So final pressure is T1, T2 over T1, which is plug in these numbers. And if I'm not mistaken, it's like 0.99.
It was. Hey, Mr. Taylor, I have a question. I want to know if this works all the time. Can I see the marker real quick?
Could you just cross it? That's what you said.
Yeah, that's what I did. Oh, look at that catch. Anyways. Okay, so can I do it like this right here? 0.7 with the atmospheres. So I got the right answer, but I don't know if this worked every time. You did 299.
Isn't that what I just did?
I don't
Yes.
know.
That is, he just set it up in the formula where you put the T2 on top to get it from the bottom.
Well, Miss Taylor, sorry. You know, here you go. I told you it was gonna be quick though.
Yep, that was quick. Yep. What's question C?
I don't have my answer.
In terms of kinetic molecular theory, briefly explain why the pressure of CO2 in a gas in the container changes as it is heated to 425 Kelvin.
What is the kinetic molecular theory?
All substances are made up of particles that are in constant random motion, and they are always colliding with the walls of their container.
Okay, so increasing or decreasing the temperature is not going to change the fact that those are particles in the container, right? So that's irrelevant. But it's going to increase the constant random motion, right?
Makes sense.
Heat them up, speed them up, correct?
Yes.
Increases the constant random motion, which makes the collisions with the particles in their walls of their container more frequent and with greater force. That's where pressure comes from. Okay, how do you blowing up a balloon? What's happening is air molecules inside the balloon are beating on the inside of the balloon and making it expand. Okay. So increasing or decreasing temperature affects that constant random motion and collisions part of the kinetic molecular theory.
I think I only got, I got half of that right, but I think that's because I said, I didn't mention how it was constantly in motion. I just said that like them bouncing off.
Did you
I
get
didn't
one?
say nothing.
I got one.
Yeah, it's just 1 point. Yeah, the second question, everything was just 1 point.
Oh,
Question 21, everything was 2 points. Question 22, everything was 1 point. So if you got 1 point, you had
So when the temperature increases, it makes them
a constant random motion and collisions.
And that shows in the ideal gas law, doesn't it? Because pressure and temperature are directly proportional. I'm so excited.
What's the next one?
Okay, so the student measures the actual pressure. Sorry.
Question, I don't know what the
I'm talking about next unit.
Oh, next unit. I thought you said next unit.
I was like,
Next question. Next unit is chemical reactions.
How is that?
What's that? It's the rice tables and all that type of stuff.
Yeah, and all
I
that
don't
stuff.
know.
I've
Good
already
at rice
made-
tables.
Rice table.
Oh, rice tables.
But it's different.
I just
though.
wish that
Because like what we did, like the synthesis and decomposition is like that.
Okay.
But
Hey,
it's
We
like
so
now.
gotta
we're
write
more
balance
difficult.
equations, we gotta do the rice table, so we gotta add redox reactions that we
Yeah.
didn't do last year, those are.
Those are tricky. Okay. So, Mr. Kendall, for number D, for letter D,
What is the question?
the student measures the actual pressure of the CO2 gas in the container at 425 degrees
So
Celsius.
CO2 is not an ideal
Kelvin.
gas. CO2 is not ideal gas because it's fairly large and has reasonable intermolecular forces. So what makes an ideal gas ideal is that it has zero volume, which means the molecule has no size, which obviously is not true for anything. And it doesn't have any intermolecular forces. And CO2 is relatively large, molar mass of 44, and it has some limit dispersion that's relatively significant. So the actual pressure and what the ideal gas law says the pressure is.
He's less.
Alright, so
It is
are
less.
you ready for these MCQs?
Because
Bill Williams developing a question for me
yeah,
now.
I am. If the laws and contain less. You got the question right. Let me make sure for our reads. Y'all can go ahead. I need to make sure.
What are you making sure?
Where's
Like,
the-
I'm trying to see.
Hey, what did you say?
I didn't say CO2. I didn't say that in construction. I said I did. I said CO2 temperature zero volume. It's causing a collide. Oh, they collide less, not faster. Right?
Yeah.
I
Yeah.
said less pressure. To collide less.
All right, give me a multiple choice question.
Okay, so number 4. I'm just gonna just go up here and just read
No,
through
we're
this.
not. Where are you going? Where are you going? Just read it to the class. They all have a copy of it in front of them. I'm the only one that doesn't.
Oh, I got that.
I don't like reading.
And then
Okay.
do number 7 after that.
All right, so I see on my answer key.
Oh, let's do this.
Oh, it is?
I was looking like that.
Oh, here it goes, on cheat. But anyways, okay, so for the diagram above is a molecular model of a gaseous diatomic element that is just above its boiling point. Intermolecular forces between the gas molecules will cause them to condense into the liquid phase if the temperature is lowered. Which of the following best describes how the model is limited in its depiction of the phenomenon? Period. I said that right.
It is not.
Now, see, I put B, but the answer is D.
I put D.
You know what B is?
B says it does not show how the interactions between ions and the induced molecular dipoles result in a net force of attraction between the molecules.
There's no ions there.
Okay, so B is, it does not show how the temporary fluctuating
Very good.
dipoles.
Temporary dipoles.
And you talk, I remember, I guess that was the answer because you literally
Took
said
those two
that.
molecules like yesterday and made them
Oh,
all
'cause
each
they-
other
'cause they
right there. It
bang.
said temporary dipoles. Yeah, did I not? Did I not take those two
Yeah.
wooden methanes and said,
Yeah.
watch this?
Oh, yeah, because you said there's a lot of things floating around. So they're going boom, then they're going to just go back, but then they're going to
Exactly
boom
what it
again with
said,
somebody
yeah.
else.
And you did that when you told us to talk.
I feel so
Yeah.
dumb.
And he said, remember, temporary dipole.
But I
did
think,
say
And that said in my head, you know.
yeah, I think I just looked at
Next
fluctuating, like I said, I don't know what that
Seven,
means.
let
so I
me
just
speed up
looked at
number
B.
7.
Number 7.
Okay.
Yeah, which of the following is closest to the frequency of light with photon energy of 3.3 times 10 to the negative
We
19?
did that one in class.
I don't know how I like.
It's the exact same question in class.
Not-
Divided by Planck's constant. Which is the answer.
Yeah, you do 3.3 divided by that.
E equals
There was a
H.
formula sheet on it.
We did that one in class. That exact question.
There was a
Number
formula.
6? Number 6.
There's a formula sheet on here.
Oh, yeah, that
That
one.
thing-
Did you work out
All
something?
right? Read
Yeah,
it
well,
for us.
actually,
Today we're doing
I
number
did that.
6. It's got the little graph chart looking thing at the top.
The student performed a fractional distillation of a mixture of two straight chain hydrocarbons, C7H16 and C8H8. Using 4 clean dry flasks, the student collected the distillate over the volume ranges A, B, C, and D, shown in the graph above. Over what volume range would the student collect the distillate of the compound with the stronger intermolecular forces?
Should be one at the highest temperature.
Yes.
So that looks like 120 degrees from here. So that volume range is 30 to 45.
so highest temperature.
Heat.
So
Right.
it's the one with the highest.
Highest temperature, stronger than liquid force, right? Highest
Actually,
boiling.
did you get number 9?
Huh?
Did you get number 9?
Number 9?
All right,
No.
Okay,
No,
can we
no.
do number
That is
9?
number 9.
what's number 9?
A 2-liter container will hold about 4 grams of which of the following gases at 0 Kelvin and 1 atmosphere?
0 Celsius.
Oh, sorry. Celsius. Sorry. Celsius. And then it's SO2, N2SO. I mean CO2, C4H8. I was so lost.
I
So
think
it's how big's the container?
2 liters. 2 liters.
2 liters.
Wouldn't we use the ideal gas?
Whichever one of them is about 40 grams per mole.
You telling me that I use the ideal gas law, or I have to use the molarity?
You can, yes.
I forgot.
Wait a
Oh,
minute.
yeah, dude.
So
Cause I use PV, and then I put 0 degrees Celsius to.
what did it give you? It gave you pressure, volume, temperature, right?
Yeah, so I use the ideal gas law.
Use ideal gas law to get the moles.
Yeah, and then I turn them into
Oh,
grams.
wow.
But this is what I got.
There's a shortcut to it I need to show you.
But like whenever I did my grams, I got those. Cause I did the ideal
What
gas
was the
law.
number of moles when you calculated in?
When I calculated, yeah, I think, I don't know.
Should be about 0.1.
N, 0.1, I got 2.
No, the little n in PV equals nRT,
Oh, LOL. 0.0892.
which is about 0.1.
Yeah, yeah. So then I did all
So
that.
4 grams is about 1/10 of a mole of something that has a molar mass of about 40.
Well, how am I supposed to do that?
That's pretty simple math.
Mr. Cato, now we all know.
Come on.
I'm not good at that.
Pretty simple math.
Look, okay, so I got 3.93, so I thought that was the closest to 4.0, because in this one I got 5.71.
Look, here's the long way.
Okay.
Show us the long way.
Now, look, the long way, which is fine, not that long way.
At least I got that
Take the
right.
P, the V, and the T that they gave you in the question, right?
Mhm.
Looking in ideal gas law, and it says that that container holds that many moles, right?
Mhm.
Okay? All right, well, if it's 4 grams in that many moles,
Oh,
what's 4 divided by that number? Somebody tell me on the calculator.
4 divided by 0.089. 44.94. And then we pick which one is best.
That sounds really close to 4401, which would be carbon dioxide. Is that one of the choices?
Yeah, see?
What about that? Is that the right answer?
Oh,
About
no.
that.
Miss Carter, you know what? Miss Carter, you did not show us that.
Right.
Like, you did not show
Do
us
not
that.
show us that.
So how are we supposed to know that?
You're
Right.
supposed to figure it out.
No, Miss Carter.
Kato, this is what we're talking about.
But this is, oh, wait a minute, this AP class, we gotta figure stuff out. We're not gonna have an answer to everything. You
No.
need to just memorize it.
Okay, tell me the way that I did it wrong. Because I started
Did
off.
you get the right answer?
No, but
Then the answer where you did it was wrong.
But can you show me why?
I just showed you why. I just showed you how to do it right there. I just showed you how to do it.
What time we get out of here? 49?
What is, what do you want me to show you? If you did it some other way, you did it wrong.
So, okay, so I would have to divide that by 4.
And I'm probably not gonna
No,
be.
you divide 4 by that,
For what?
and then match it up to the molar masses.
Because you have neurons?
No.
Closest one is 44.
No.
5
How
seconds.
did I miss 13?
No, but
All right. What happened, fun?
That's what I did with the
You know,
first two
I want to
tests.
be on your good side, so I'm not gonna ask you no more questions today.
All right, good deal.
Good deal.
Hey, I want to be on your good side. I'm not gonna bother you. Well, I am gonna bother you, but not today.
Remind me tomorrow to show you a shortcut to that.
Okay.
It's not that much shorter, but it's a little bit.
Well, at least I had the right idea. Just the wrong
It's
answer.
these FRs.
Like, at least I had the right idea.
FRQ.